Hi, in this video I want to show you how to calculate the electrostatic force using Coulomb's law. So we have an example problem here. It says a balloon with a charge of 10.5 microcoulombs is brought within 0.77 meters of a bubble with a charge of negative 13.3 microcoulombs. So how much electrostatic force is between them? I've tried to illustrate the situation here with point charges. So this is the balloon, this is the bubble. And this little symbol is micro. I'm going to rewrite this. I typically try to label my charges as Q1 and Q2 just to remind myself, what they are. And I'm going to rewrite this as 10.5. And instead of writing micro, I'm going to use my knowledge of what micro means. Micro just means times 10 to the negative 6. So I'm going to write 10.5, and instead of writing micro, I'm going to just write times 10 to the negative 6 coulombs here. Same thing down here, I'm going to write negative 13.3 times 10 to the negative 6 coulombs for Q2. That's my second charge. And the distance is 0.77 meters. So you got to make sure it's in meters, not centimeters or anything else like that, because we want our answer to be in newtons for the force. So we should also write down our constant when we're dealing with problems involving Newton or Coulomb's law, 8.99 times 10 to the 9, and that is newtons times meter squared over Coulomb squared. So this is all my known information. I'm going to use this information to substitute into Coulomb's law over here. So I'm solving for the electrostatic force. I have 8.99. I'm going to write E9 to simplify, so I don't have to write so much every time. I'm going to keep the units in here. I like to always have my units in the problem with me because it just lets me see how they work out together. So my Q1 is 10.5 microcoulombs. Q2 is negative 13.3 microcoulombs. And then dividing by the distance squared. Okay, at this step I'm going to multiply. And this number, this K number, is out in front of my fraction here. However, this is really over 1. And so I can combine the denominators here by multiplying these two numbers together, and I can combine the numerators here by multiplying all three of these numbers across the top. So that's what I'm going to do. I'm going to multiply K times Q1 times Q2 all at the same time. It's just easier that way. So when I do that, I get negative 1.26. And I'll have units of newtons times meters squared after that. The Coulomb squared will cancel out with the coulombs and the coulombs here. And then my distance is squared, so it's going to be 0.593 meters squared. Now newtons times meter squared divided by meter squared gets rid of my meter squared altogether. And so my electrostatic force is equal to negative 2.12 newtons. And I want to look at this negative sign. What does that negative sign mean here? Because our charges were positive and negative to begin with, if you multiply a positive times a negative, it's always going to be negative. And the negative sign in this case just simply means attraction. So this is an attractive force between the two objects. Now, if it was positive, that would tell me that my two charges up here are the same sign. Either they were both positive, and so positive times positive is positive, or they could both be negative, and a negative times a negative becomes positive. So positive would mean that it's a repelling force. If it's negative, that means they're opposite charges and it's an attractive force. So that's all I've got for you in this video. Remember, shortcuts make long delays.